In this video, we're going to take a look at how I created this vet in Solidworks using surfaces. This is kind of a long feature manager with a lot of steps and a lot of features in it. And we're just going to get an overview of the big picture things. So let's get rolling. First, let's roll the feature manager back. And to do that, I'm just going to right click and select the rollback. Now I started with 3 sketches. One is a straight line just to get an idea for a characteristic size. Usually on an automobile like this, I'll do the wheelbase. And I also created a sketch picture. So we show the sketch to get the sketch picture. And here I've got the wheelbase driving the overall size of the sketch. I've also got a top image and a front image. Actually, the front image is a front and a rear image, so I can get the headlights and the taillights to trace over. Next, I drew a curve that goes around the car and kind of gives me that breaking edge that goes all the way around. And this is created as a projected curve from a couple of spline sketches, and I used curvature comb to get those sorted out. And then I set up a couple of planes across the part, and then I start creating some sketches that represent cross sections of the car. The first actual surface that I create is the top surface, which is going to be a series of sketches that make up the hood and some of the sides, and a lot of this is going to get trimmed away, but it's there as a starting reference. And then I've also created a cockpit reference. So this is for the windshield, the roof, and the special fastback hatch that you see on these vets. From here, a series of planes, and one of the features I wanted to make sure to get in was the cyclone on the back of the car. That's one of the main characteristics of this particular Corvette. And then the lower panels that went all the way around for the grille in front, the underside of the fenders, and whatnot. And then, of course, the windshield goes in here as well. I'm making sure that all of these surfaces overlap with one another. And one of the things that I want to turn on here is the shaded with edge display. This makes everything just a little bit easier to work with, being able to see the edges. Plus, I've got the setting turned on where open edges for surfaces turn into this light blue color. This helps you identify when surfaces are not joined together into separate surface body. Sometimes I have to create an extend feature because my original surfaces were not long enough to mutually trim. So that's what's been done in this case. And then I trim these together. And notice that as these surfaces become trimmed to one another, the edges between them become black instead of light blue. Now in this case, I found that I needed to create the windshield surface separately, and I just used a replace face. This was probably to avoid a lot of broken references down the line. Variable radius fillet around there, and broke out a section on the hood to put in one of the flares that goes on the top of this car. This shape, if you're familiar with the car, would have probably been easier to create all in one piece when I did the top surface, but in this case I didn't do that. I chose to make these as separate surfaces, which allows, I think, a little bit more definition and a little bit more precision. That fender bulge was created with a boundary surface, and it had a spline that went across the top to help define where that goes. And we did the same thing with the fender bulge at the rear of the car. And one of the things that I like to show here, the show tangent edges in Phantom, so that you get a display like this, and you can tell that edges that are not tangent are shown in a hard line. And so as you look around your model, you get a good idea of which surfaces are doing better than other surfaces. While creating this, one of the things that I worried about a lot was how the tail end of this cyclone, when it comes to a point and it meets everything else, how is this going to all flow together? And in this case, rather than trying to get all of these features to come together naturally, I use what we call the atomic bomb fillet, where I just cut it out and I will fill this in with a surface fill later so that everything blends together nicely. When you have trim around a window, like right here, there are a couple of ways to do this. But the way that I prefer is to use this extrude function. I'm not making a solid, and I'm not really extruding a surface. The option in the Surface Extrude allows you to select a couple of faces, and then Solidworks will push these out as if you were extruding, but there is no back on it. It's still a hollow surface. So if we take a look at this from the inside, you can see here what's happening. And I'll just zoom up on this. It's pushing this out, and it's going to hollow out the back end. So it's like thickening a surface, but without the thickness and without making it a solid. So if I click the green check on this and we take a look at how this works out, it makes that piece of trim very nicely. Makes it stand out from the rest of the surface. And that's a function of the Surface Extrude function. I think this is something that a lot of people don't know much about. It saves a lot of time, because if you were to do this manually, you'd have to offset a surface, you'd split a couple of surfaces, you'd probably have to create a couple of ruled surfaces, and then you'd have to get it all to trim back together very nicely. That's a great function. Just remember that as part of the Surface Extrude. Added some more of that with the side chrome, and start working now on the hood detail. It's always a debate when you work on a car like this that's symmetrical, and you can benefit by just working on half of it. But at the same time, any features that go along the center line, like this hood detail, can cause some extra difficulties. Sometimes you're tempted to leave these until the end, but somehow that never works out the way it should. This was added with the help of a fill feature and a little reference surface that I created in here. So the reference surface closes that open loop, and the fill surface closes the gap using the curvature setting along the reference surface. Everything else is contact, and these edges are smoothed over with fillets later on. I'm not always a fan. In fact, I'm not usually a fan of using fillets to smooth things out, but sometimes it works. Sometimes it's an acceptable compromise. Okay, the rear window extrude. I'm going to use this trick again. The trim around the rear window gets lifted up. And this is done by creating a split line around the window, selecting the surface inside that split line, and extruding that a certain distance. And it will always extrude it in a particular direction.